the idea is to make the web processing services which already exist easier to use in the climate context. If you're familiar with OGC services, usually have this, so it's a service, and usually you have this get capability method. And with the web processing service, if you call the get capabilities, you will get a list of the available processes which you could run. And with this wide process, you get more details about a specific process algorithm, mainly about the input parameters and output parameters. And with execute, you can run the process. The process could be run synchronously, so you send a request and you need to wait, and after maybe some seconds you get an answer, or you could run it asynchronously. So you send a request and you get an answer immediately, which provides just a link to a document where the current status is updated. So you need to pause this status document to see if the process is succeeded, maybe it's a percentage and the log message, and maybe if it has failed. So you have your processes. The WPS is just a layer around it. It's more kind of a communication protocol. And then you may have your web application. And you ask for a specific process. You get the parameters back, the inputs and outputs parameters. And then you can send a request, maybe with an .cdf files and additional parameters, and maybe you get back a picture. Because of the self-descriptiveness, self-describing capabilities of WPS, it's easy to set up a generic user interface. So you can just attach the WPS, and you already know on the technical way how you can communicate with it. When you want to program a new process, it's just a function, and it has input and output parameters. And if it would be very easy, you could, if it's Python, you could add a decorator, and it would generate just the input and output parameter description your WPS needs. But usually you have to do a bit more about it. And if you have such a process, you could run, if you want to, could run a simple GET request with the name of your function, and you run an execute, and you provide the input parameters. So for an .cdf file, you could provide a URL, and maybe you want to do something with just variable, and you get the results then. If you have all of Birdhouse, there are several components. So there might be several WPS services, and then there's the Phoenix web application. It's a user interface, a web front end, and you can register those WPS services in a catalog service, and Phoenix can then interact with those processes. I will show that later in a demonstration. And additionally, we have data sources like the ECF climate data archive or threads catalogs, or maybe the Swift cloud. And the Phoenix has user interfaces to select data from these climate data storages, and it will feed those processes with these data. So for doing this, the current way I'm doing this, the user process usually has just says that it needs .cdf files. And I have a special WPS manifold which takes care about downloading data and caching them. And then there's a workflow process, which is called by the Phoenix user interface, which will call all the process of manifold, downloading data, caching it, and then the real process provided by the user is called. The results of the processes would be published to a catalog service so that they could be used as input data again, or you could visualize the data with the WPMW and Web Map service. That's a screenshot of Phoenix, but we'll show it later. Additionally, there's a command line, WPS client. Because of the generic way, it's easy to set up the user interface. And this command line, you just have to tell which WPS you want to talk to, and then it will show you the available processes with the description and all the detailed parameters of the processes, and you can execute a process. The Birdhouse sets up the WPS services and all other services, and usually it's a Python application with Whiskey, and then there's a Whiskey server Unicorn, and in front of it a web service, web server Nginx, and these services are controlled by the Python module supervisor, which starts and stops those services and can monitor if the services are still available. You could call all these processes on its own, but the Birdhouse has already a workflow process. And this workflow process is about searching data, downloading it, caching it, then running the user-provided process, and maybe publish the data. There are many services, and there are these processes and algorithms, and they have a lot of dependencies, and somehow I need to manage all these. And I'm using two tools for this. One is Conda. It's in Python, and it's a package manager for Python and other packages, if you like. And the other one is build-out, also in Python. I'm using build-out to set up complete applications. So, for example, a WPS service with all dependencies and configuration files. With Conda, you can install packages, binary, available for several platforms, and you can also provide your own receipts and build your own packages and upload them to channels. So I have my Birdhouse channel to provide packages that are not available in the default channels. To write a Conda receipt is quite easy. It's just a YAML configuration file where it's described the source, the version, and the dependencies. And then you have a build script where you can build your application, your package. And then you can upload those packages to the Anaconda server so that they are available for others as well. Build out is in Python, and I haven't seen that it's widely used, but it's quite useful for me, and I can use it to set up a whole application with all the dependencies, with all configuration files. I can customize those configuration files, and I can set up the services itself with supervisor and so on. And usually you just have a build-out configuration file, and it's not telling that much because most of it is in those receipts. So it's already coming with default receipts, but you can also extend it with your own receipts. So I have a receipt to install Conda packages, and I've also received to set up a WPS service. I can configure it with another title, another hostname, and it will do it all for me. You can extend filter out with receipts. It's a Python module. You usually have to implement an install method and maybe an update method. And you get all the configuration options which are mentioned in the build-out configuration as input. So I'm using those build-out and Conda receipts extensively, and if you want to get a WPS running, for example, the EMU example WPS, you just need to clone it from GitHub, and then you can run make install, which will call build out. This will set up everything that's necessary, and this make start. You will start the service with supervisor. And if you want to customize the installation, there's a custom CFG, and this will override the settings in the build out. I'm also starting to use Docker, but mainly for testing and maybe later on also for deployment. And for Docker, you need a Docker file to generate your Docker image. And because I have already this common scheme to set up my application, all these Docker files look pretty much the same. So it's just getting the source and run make install and maybe configure the ports and so. Those Docker files, Docker images are available on Docker Hub if you want to try. The WPS has no security on its own. You can run it on HTTPS. You could use basic authentication, but if you have several of them, or if you want to work in a federation, this is not sufficient. And so it would be easier if we could have a simple authentication, maybe only token-based, string tokens. And these string tokens would be part of the URL, or maybe in the header of the request. And then this request goes with the string token to the application service. And then there's a security middleware which checks if this token is valid or not. If it's valid, you can run the process. There's a prototype for this.
Carsten, sorry. You say you're still working. You're working on that part. You haven't implemented that yet, or it is?
Yes, that's the next slide. Now there's a prototype. There's a switcher, and it's already functional, so you can try. But it's not really production, and it needs also some discussion about how it should work. So in the switcher is so we have a client. The client sends a WPS request with a token URL on the header. It goes to the WSGI application server, goes to the security middleware. The middleware checks if this token is valid or not. And then you can run the request or not. And if the token is not valid, you will get an exception which is conform to the OWS standard. In addition, you could also use the OWS proxy, so we can register other OWS services like the Web Map service or Web Processing Service, and it's working as a proxy, and you have all the service behind the same URL, so on the same port, and it's also aware of the protocol. So it will do also the remapping of the URLs. And then it needs to control the registration of the services, and that users get tokens. And there's a XML RPC interface to access this administrative part of it. So that's basically it. There are some links, and I could show now a demo, or maybe you have some questions already.
Well, I have some questions, but let's, if anybody, but I'm willing to wait until after the demo.
Okay.
Does anybody else have a question they want to ask right now? Okay, yeah, go ahead, Carsten.
Yeah. I need my browser now.
Oh yeah, so maybe stop sharing that application and then go back to sharing either a browser or your desktop or.
Okay. Can you see my browser?
Yes.
Yes. Okay.
Yes.
So this is a Phoenix web application. I can log in, and you have several possibilities to log in with GitHub or with LDAP or OpenID. And it's focused on using my local account here. So, you have the possibility to register WPS services. There are already 2, Hummingbird, Flying Pigeon. I register a new one. I enter the URL, and it's a web processing service. I can register it, and now it's inside here. The registered processes are listed under processes. So I can go to the emu, and it does for testing, and I can maybe run Hello World. And the job is added to the task queue, and it's monitored. Then you get it in the results, and you have a logging of which is coming from the WPS, and you can see the outputs. And the Phoenix is just aware of the WPS protocol, so it does not know what these processes do, because I can just register any available WPS, and I can talk to them.
So, Carsten, did you show us doing the described service? I assume it can do the described service request or whatever it is from that interface. Did you show us that?
You mean this one?
Yes.
Yeah, that's where I register the service.
Right, but isn't there a described? I mean, how did you figure out what the inputs were?
I mean, these things here. It's because I'm using the catalog service. It's not necessary, but I have it installed. And the catalog service is also aware of other OGC services, and it fetches those metadata from the service.
But I mean, how did you know? How does this tool know how to interact with a specific web processing service?
Because of the behavior of WPS. Because I go to this WPS service, and then it does the get capabilities. The get capabilities lists me all the processes that are available with the description, title, abstract, version number, and then I go to a specific process. this one. Then
okay.
Then I ask describe process, and it lists me all the input parameters that are available.
Okay. So this page was generated from the describe service request or whatever.
Yes.
Yeah. Okay.
So the Phoenix just knows about the WPS, but it does not know about what's behind those processes.
So is Phoenix something? Phoenix is something you also wrote?
Yes. I haven't seen anything I could use otherwise.
Yeah.
It makes it more comfortable to interact with those services.
Right.
So I've entered another parameter, now I do submit, and the task is running. It's very short, and I get results. And these log messages, I'm getting those because I monitor the execution. It's running asynchronously, and I pull this status document, and then I get a log message if it's written there, and the percentage. So I know what's going on in this process. And I get also the results, and the result is the same. It's a generic XML document. So there are two types. Maybe I can show it again. The WPS knows two types of input parameters: the literal ones, like integers and strings and floats, booleans, and the complex ones. And that could be files with the MIME type, like XML files, NetCDF files, images. These are the basic two types that are used in the WPS. So I go further. I can register also threads catalogs. So I need a URL. I take this one. And I have to give it a name. And tell it that's threads catalogs, and I register this one in the catalog. And then I can go to the Solar, and I can index NetCDF files that are available on this threads catalog. So I do it now. It's just one page, so it should not take long. It's done. So now I'm using the wizard, and I choose the Web Processing Service, and I choose one of the processes. I choose this time the compliance checker by IOSS. Next. Then I can enter the parameters needed by this process, and this is also generic, so I didn't know it in advance what parameters I have to enter here. And it's fed with NetCDF files, and then I go to the Solar search, and here I can select data. So I'm using whatever pressure and not so many files. It's not too comfortable, but at least one can see how it works. So I have 10 files. Hopefully that's okay. Or maybe I tried only with one. 7 files, okay. So I take these files, and then I start the process. And this time, I do not start the CF checker process directly, but I start the workflow process. And this workflow process gets the input parameters for the source, so it's fed with a filter, and it fetches now the data for me, and then this data will be fed into the C checker. And hopefully it works. So maybe that was, I don't know how big this data was.
So you're running just to make sure I understand, you're running this compliance checker locally, right? I mean, not locally, but you're providing this checking, you're providing this checker service yourself, right?
Yes.
Okay.
It's not yours. So it's still fetching data. So I can show these files of another one. I have one today, and that was running much faster. And I get the report of the checker. And it's just this text file. So
that's super cool.
So it's done, and nice results. It's not, it usually complains. I take another process. This one, I have some favorites here so that I do not have to type everything again. So this process from the flying pigeon, calculation, robustness of an ensemble, whatever it does, but the result will be an image. I need to enter some parameters. I leave it to default except for the variable. And it needs SCF files. Now I get data from your system climate archive. And I've already set a pre-filter, but I could change it. So it's fetching Audex, historical, RCP85 experiment, task survivor, and so on, monthly time frequency. So it takes those 12 data sets, and then I started. Why this one is running, I can always...
So just, Carsten, can I just stop you for a second, just to make sure I understand what you just did there. You have a web processing service that is computing some statistics or some skill assessment or something on some ensemble data, but part of the input to that, the files that you want it to process, you created by doing essentially some search using another web processing service to define the inputs for the ensemble robustness calculation, or?
I go to it again. 1 moment. So next.
Okay, so
this one.
Are these inputs being requested by the ensemble service? Yeah. Okay.
I can choose whatever I like. So the data needs to fit in this time, because I can just select data on the ESGF, whatever it provides, and I need to make sure that it fits to my algorithm. I don't know that. It just know it needs NetCDF files. And here I can select the data, and again, when I start the process, this workflow process is started, and it takes this selection filter and fetches the data from ESGF. And I also need a certificate, which is already saved here, and then the real process is started with this data.
So this ESGF search is also a web processing service?
This user interface, now I'm just have JavaScript here to interact with this service.
Okay.
So I don't have a WPS for this.
Okay.
It's already very simple to use.
Uh-huh.
But yeah, in fact, it's right. The search is the process itself. When you're when you're searching your data, you're triggering the search service in the background.
When the workflow started, yes, that's true. But in the interface, I'm just using JavaScript. This makes this selection.
Okay.
So when I have a result, and this time I get an image. And these can explain what it means, but that's not that important now. And then there's a PDF file here, and I can show it on the WMS. It's the NC WMS2, the standalone version, not coming the one to the scripts. The WMS has access to the output area, so that's how I get. I have the URL of the output, and then I can guess how I need to power the WMS to get this image. Then I could publish the result to the catalog service, but that's broken now. And if it's in the catalog service, I could use the catalog service also as a data input. I can take the URL of this file if I want. Then I go to Processes, to Hummingbird, and then I could run CDOS info. Now I'm running the process directly without the workflow. I give it the URL of a .tzf file, and then I execute it. And it was not that big. And I get just the CDOS info result as a text file. So that's the Phoenix part. I could also show the Birdie command line if you like.
Do you also have, well, actually, maybe we should see if there's any questions at this point.
Hi, Carsten. This is Carl from the USGS. Well, we're called the Office of Water Information now. I guess until very recently, our name was the Center for Integrated Data Analytics. But same rows, different name, I suppose. This is a really impressive looking app. I really like the look at the Phoenix app. So for the geodata portal here, one of the things that we have been hoping to accomplish is some sort of dashboard-like monitoring and process management solution, but we haven't quite had the time to embark on that yet. So a web app like this is particularly attractive to us, and we'll definitely be keeping it in mind as we revisit that project in the near future. I'm wondering, though, can the processes dashboard, or the monitoring dashboard rather, be used to monitor and manage processes which are not started through the Phoenix web UI, but were started by like a third-party application that can create WPS, can launch WPS processes on its own?
There was a question, but it didn't.
I think the question was, I mean, you could use this interface. I think you showed us. You could connect. So they have a web processing service set up already. This geodata portal. You could add that into this existing interface. You could remove these other web processing services, and you'd be up and running, right?
Yes, you could add it. Yeah, and you could use the functionality that's available. So this is a very generic part, and with a wizard, you need to follow what is used in this workflow. So if I have processes which need .tzf files, I can feed them with data, but that's the only thing I can do in this wizard.
Sure. So can the Phoenix app in that monitoring link at the top where it says Processes Wizard Monitor, there's a table of processes. Can we monitor processes which were not started by the Phoenix UI but were started by a different client to the WPS?
Okay. No, it's just talking to it. It's talking to the WPS directly. So I have no application with additional monitoring or so.
Okay. So, for example, if you started, does the Birdie client talk to the Phoenix web app, or does it just create WPS?
The Birdie client, I could show it if you like, but the Birdie client is just a different client next to the Phoenix. So it does know the WPS protocol, and I tell him which WPS service it should take, and it can just run processes against this WPS service. But there's no monitoring component around. This would be maybe a part of the Twitcher, because that's something that's in front of the WPS, and you could add additional functionality there. So the Phoenix would not talk directly to the WPS service itself, but first to the Twitcher, and it could do some monitoring, and this would be the same for the Phoenix, for the Birdie client.
Okay, cool. So,
I don't have it, but it could be something we could put in a kind of a middleware in front of the WPS services.
Sure. So, are processes that are started off by the Birdie command line clients, are those visible in the Phoenix monitoring?
No, they don't know each other.
Okay, gotcha.
So they're only currently WPS services and a few different clients. But if I want to have more, like this monitoring, I would need something in front of the WPS services, which all the other clients could talk to as well.
Okay, cool.
Yeah, but I don't have it. Yeah, but it could be done this way.
Sure, yeah, and you guys have made a lot of promising progress so far, so if that becomes relevant, you've got a good foundation to build on. I'd be interested in hearing more about the Birdie client next. Do people have other questions, or should we just take a look at that?
Carl, so are there, I don't really know anything about web processing services, so I'm wondering, are there significant, is everyone using the same version of web processing services, or is there basically only a 1.0, or are there any of those kind of OGC issues floating around here with different versions?
So for the protocol, there's only 1.0.0 version. They have now the 2, whatever 0 version, but there are no implementations yet there for the version 2. And the main difference between those versions is that version 2 has a cancel function, which is unfortunately missing in version 1. So the protocol has provides no ability to cancel a process currently. But with version 2, this will be possible.
No ability to what? Cancel a process?
Yeah.
Okay.
Yeah, Carson, thanks for jumping in. Yeah, that answers the question.
Okay. Should I go to the Birdie client?
It sounds like it. I mean, Alex, yeah. Micah or Alex, do you guys have any questions?
I just would like to say I have to leave. They are closing the door, and then I have no chance to get out of the campus here. And I would like to mention that we have a mailing list if you are interested. Well, we are sending around some news from time to time, so if you would like to be on the list, then Carsten can give you the appropriate link for that.
Okay, thank you so much for joining us so late in the evening there.
Yeah, sure, no problem. Bye-bye.
Mailing list is in the documentation. I can send around it. So,
okay.
Up to the Birdie command line.
Sounds good.
Okay. Then I need to stop sharing. Oh, maybe this will. So do you see the console?
Yep.
Yeah. Okay. So you can, it's called birdhouse minus birdie because the birdie name was already taken. You can store it from Conda. I have only one hand, so I can't type that much. But I've already installed it with Conda and Conda. It's very basic. It's not doing that much yet. And I can export the URL of a WPS service so that the birdie knows to which WPS it should talk. Then that's the hummingbird. And then I type birdie minus H, and it does the get capabilities request. So it gets a list of all these processes with description. And then I choose, let's see, checker. So do a minus H, so it does a describe process request, and I get the input parameters, and also the output. I can select output parameters. I usually take all of them. Then I could run it. The data set, and I have a local one here. I think it's okay. So, and it will run this process remotely. Execute it, and it was not that long. And I get the status messages, and the output is a link to the storage for the WPS services. So I open this link, and I see the results. So it's basically the same as the Phoenix, but on the command line, and it's easier to program. A web interface is much more work to do.
So is this using your Pi? Is PyWS? Is that what's being used here, or?
The WPS service, I'm using PyWPS because everything I do it in Python, and PyWS is the implementation for it. And for the client library, I'm using the OWS lib, which has also a WPS module.
Okay.
And currently, the implementations are not always 100%. So the OWS lib can only talk to WPS in the asynchronous mode. Sometimes you would like to use the synchronous mode, but currently it talks only in asynchronous mode.
Okay.
Does the Birdie client currently support uploading files, or would they have to be accessible via a URL?
The best way to provide the data is the URL. So the data will be downloaded on the server side. But the WPS allows you also to send the data with the request. I could do it. So I have taken localhost, so it knew it's local, so it did my URLs, but I take a different address. So this one is remote, or expected to be remote. And then I don't send this one, but a smaller file, and this file will be sent with the request. If I take a larger file, I have to do something about it because it will complete. There are several, so that's too much for him. several hundred megabytes or so, 130 megabytes or so. But it's possible to send data with the request, but it would be better to write it as a URL.
Right. Cool. Thanks.
So, Carsten, were you required to use web processing services as as part of some European Union directive, or were you kind of just interested in them, or I mean, have you really felt that this is like the best solution for your workflows, for turning these workflows into services?
First of all, I'm interested in, and I was working in another project which tried to establish services for the climate community, but they implemented everything on their own. It was a very complex system, and it did not work. So the WPS is more lightweight to use, and it has a standard interface, so it can communicate also with others. So this is an approach to provide services for the climate community. And there are other people also working on WPS processes at AMI, the Climate for Impact. But it's mainly supporter, and it has a WPS service behind. And also the ESGF people want to put computing next to their data. They are also using WPS.
Yeah.
So you can.
So go ahead. Sorry, somebody else have a question? So I just have. I mean, so again, as sort of a beginner. So if we have some Python program that's doing some processing, say, for instance, we want to run an offline oil spill model. We want to feed it a netcdf file. We want to feed it some initial location of the oil spill, and then we want to have it go and calculate all the particle trajectories for some period of time. We have all that. Let's say we have all that running in Python. To turn it into a web processing service, what would be the tutorial that we would follow to turn that into a web processing service?
I can show you the implementation of a process. Maybe go to another one. So I take the IOSS again, and can you see it?
Yes.
Yes. So I'm using the PyWPS. So how you bring your processes into the WPS depends on the implementation. But what they always need is you need to describe your input and output parameters. Like if you do a command line, it's basically the same. So for WPS, you have a class, and it's a subclass of WPS process. Then you give it your process a name and a description, and it needs to be asynchronously. That's meant by these two parameters. And then you describe your input parameters, so a complex input parameter for netcdf files, and some additional parameters in literal type, maybe, whatever you need. And then you may have one or more output parameters. In this case, I have a text file. It's also a complex parameter. And then you have an execute, and this execute has access to the parameters provided. And everything up, down is up to you. So if you have your processes already running, you just get fed it with the input parameters, and you have to just bring back an output parameter, and that's it. So it's to write a WPS description with quite easy.
Okay. Yep. So this, these examples, like this example of the web processing service for the compliance checker, the IU's compliance checker is out on your GitHub. If we want to look at this later, and any of these other services.
It's in the Hummingbird, so I can send
Yep.
you a link if you like.
Yeah, no, I can find it. Yeah, I've seen it before. Okay. All right.
I've seen on the iOS page that they also started to set up the processing for the checker, so with an interface and also their own processes. But it could also be done with the WPS, so you don't need to do your own processing. Yeah.
Oh, you mean the online service for doing the compliance checking?
Yeah.
Yeah. Okay. Well, maybe this will get us going. All right. So it's it's 2 minutes to 3. That was a super impressive presentation. I can think of all sorts of things that we could do with some of these tools. So thank you so much for taking time, and especially late in the day there in Germany, to present this to us. I really appreciate it. And any last words from anyone else? All right. Well, thank. Oh, sorry.
Just wanted to say thanks and reiterate that this is indeed impressive.
All right. Thank you. All right. So thanks, everybody, and we'll see you in about a month.
Okay. Thanks.
Thank you.
Bye.